Hello. In this lesson, we'll explain what SD-WAN is and how it has evolved. SD-WAN stands for Software Defined Wide Area Network, and it leverages the corporate WAN as well as multi-cloud connectivity to deliver high-speed application performance. In the past, organizations purchased and operated their own servers to run applications and store critical business data. As a result, they had upfront capital expenses, and they needed to employ a team of highly trained technicians to run these servers. While expensive, the competitive advantage it gave over those who didn't computerize their businesses made it worthwhile. One early challenge was to make these servers available to various geographically distributed networks, called local area networks, or LANs. You might recall that a WAN is a computer network that spans a large geographic area and typically consists of 2 or more LANs. For example, if Acme Corporation spanned multiple cities and continents, each with their own local area network, how would they connect these LANs so that someone in the London office could connect to a database server in Singapore? Traditionally, businesses connected their LANs by way of a single dedicated service provider. Though expensive, they could control and secure this connection while providing access to critical resources. However, this method had limitations. The single point of connectivity was subject to frequent outages, which made it unreliable. In addition, because there was an increasing demand to host business applications in the cloud, known as Software as a Service, or SaaS, higher latency became an issue. SaaS applications like Salesforce, Dropbox, and Google Apps, and a greater reliance on video and voice conferencing contributed to the congestion. Businesses began to augment their connectivity by employing multiple providers or seeking more affordable broadband and other means of internet connectivity. The trend toward increasing hybrid connections and the growth of cloud applications to support underlying intelligent business decisions led to the first generation of SD-WAN. Businesses added multiple dedicated carrier links and load balancing per application traffic based on how much bandwidth was available. Although this approach seemed to solve a few bandwidth issues, it added yet another product to solve another network challenge. These point products escalate complexity to the network infrastructure. Why? Because adding multiple products from multiple vendors, each of which have separate management consoles and which often do not fully integrate with other products, becomes a management nightmare for IT security administrators. Still, the first generation of SD-WAN solved a pressing business need. Its basic load balancing techniques allowed the network to make application-intelligent business decisions on hybrid WAN links, including service provider, broadband, and long-term evolution, or LTE, which is a standard for wireless broadband communication for mobile devices and data terminals. Accurate application identification, visibility into network performance, and reliable switchover of application traffic between best-performing WAN links pivoted SD-WAN as the most sought-after WAN technology across all businesses. However, security remained a serious consideration for businesses. Even after SD-WAN adoption, businesses kept sending all their sensitive and critical application traffic to data centers for security purposes, or were forced to install a sophisticated firewall solution to inspect their direct internet access. This added another point product for security, making the network yet more complex, challenging to manage, and delaying cloud adoption. Businesses needed to address these challenges by integrating security and networking functionalities into a single, secure SD-WAN appliance. This enabled businesses to replace their multiple point products with a powerful single security appliance at a reduced cost and ease of management. A strong security posture helped businesses to use cloud applications more affordably, with lower latency, and with a direct internet connection, ensuring optimal application performance and best user experience. Continued network performance health checks ensured that the best available WAN link was chosen based on user-defined application service level agreements. Should a particular link degrade, the SD-WAN device knew to move the connection to the better performing WAN link. Today, in secure SD-WAN, intuitive business policy workflows make it easy to configure and manage the application needs, with the flexibility of prioritizing business-critical applications. A centralized management console provides single pane-of-glass visibility and telemetry to identify, troubleshoot, and resolve network issues with minimal IT staff. Comprehensive analytics on bandwidth utilization, application definition, path selection, and the security threat landscape not only provide visibility into the extended network, but helps administrators to quickly redesign policies based on historical statistics to improve network and application performance. Overall, positive outcomes of a secure SD-WAN solution are simplification, consolidation, and cost reduction, while providing much-needed optimal application performance and best user experience for the enterprise, SaaS, and Unified Communications as a Service UCaaS applications. Runtime analytics and telemetry help infrastructure teams coordinate and resolve issues in an accelerated manner, which reduces the number of support tickets and network outages. Fortinet introduced the term Secure SD-WAN, of which FortiGate is at the core, the next-generation firewall, NGFW, of Fortinet. In addition to the FortiGate device, the Secure SD-WAN solution includes other advanced networking features. Thank you for your time, and please remember to take the quiz that follows this lesson.